thanks for coming today. Our Jones speaker today is Professor Bart Miller from University of Wisconsin-Madison. So Bart's bio says a lot about him. He's a distinguished, Vilas Distinguished Achievement Professor, and his bio describes quite a bit of the activities he's involved in. He's going to talk about some of them today, in particular his work with cargo ports. Is that a good way to describe it? Some things not in his bio are that he got his PhD at University of California, Berkeley. He's an avid pilot, has his own plane. You can talk to him about that. And he spends a lot of time in Europe and around the world. In fact, on Sunday, he's going back to Madison tomorrow. On Sunday, he's flying to Australia for a couple weeks to do some work there. So with that introduction, Bart, please.
Thank you, George. It's a pleasure to be here. It's actually my first time at Dartmouth, so treat me like a new freshman. Maybe not. And thank you all for taking time out from the festivities going on campus. I'm sure with all the parties and alums back, it'll be a joyous place this weekend. Sorry, I'll miss that. Okay, so I want to talk about software securities. Software assurance, we sometimes call it, but software security. And this is not network security and authentication, identity management, and penetration testing and network monitoring. This is the security of the software development process. How does one design? How does one think about this process? How does one design secure software? How does one code and develop secure software? How do you test it? What tools are available? And then I'm going to, hopefully if I don't wave my hands too much on other early topics, talk about how we've applied that to a bunch of domains, and most recently to maritime cybersecurity. So let's, I always tell my students, if you give a security talk, you have to start off by scaring the audience. Terrify them with something that involves fear, uncertainty, and doubt. So show them something really scary. So as my legal friends would say, read this as read. Okay. Create whatever cyber disaster in your mind from your favorite movie, place it here, and we'll go on. Okay, so we're living in a crazy time with security. I started programming in the 1970s in high school. Yeah, I'm old. And with a computer, and only a few places have computers. And even through grad school, we get computers almost had computers on our desk. When I assist professors, everybody had computers on our desk. It's nothing like what's going on now. Okay, we've got what you'd expect, operating systems. We've got mobile. Mobile has created this insane proliferation of code. And I'll show you that quantitatively in a minute. But there's been nothing like this in history of the amount of software that's coming from that thing. Okay, that number is low. I just had to put a number there that was somehow justifiable. But there's so much active code that's being deployed on the web. Open source software is out there everywhere, creating these funny communities, providing infrastructure for us. The cloud, whatever that is, creates a whole nother layer of software that gives us services and virtual machines and active web services and containers. And then Internet of Things. Everything, including, given the speakers we've had recently in Wisconsin, even your underwear is going to have computers in it, or already does. Maybe you don't know that. Sorry. So this is just insane. And then when we look, and then of course big data. Everything you do is being recorded and calculated and studied, and that's creating a whole nother layer of programming that looks nothing like we've had before. Now, power plants. We've heard about power plants for decades, and we're still trying to figure out how to secure the software that runs our power plants. Transportation systems. Yes, in that there is a TCP/IP network drop inside the switch controlling that track, and it is internet accessible. Okay. I like trains. Maybe you'll never get on a train again because of this. Something of real immediate interest to us, these colored boxes that support 90% of the world's commerce are just driven by software. We'll see more about that in a little bit. Inside the avionics bay of a fighter jet or of a commercial jet like a 767, there's an enormous amount of computing power. Everywhere there's software being written in volumes that have been just unknown till now. So just as an interesting example, this is the number of apps in the Apple Store up to last July, with the latest data I could get. Thus, notice that there are more than 3 million apps. Numbers similar for Google Play, actually a little higher. Now, if you would have went to any of the graybeards in the crowd 15 years ago and said, hey, you know, back in the Windows days when there were like maybe 10,000 applications, programs that ran on Windows, and we thought that was absurdly high, and said, there's a new operating system coming. You're not going to believe it. In 10 years, there's going to be 3 million programs that run on your computer. You would have just looked at the person like they were a blathering idiot. Okay? But this is, so who's writing all this code? Well, this is from the Talby survey. This is the number of bachelor's degrees given. And it went up and up and up, and then the internet bubble burst. And then it went down, and it's climbed back up. But notice that bubble here. I mean, that's how long ago? Almost 15 years ago. And we're only barely past the level we were 15 years ago in the number of programmers we're graduating. Here's the number of majors, and the number of majors are climbing. So that's good news. But the numbers, we're talking about many orders of magnitude more software, and we're talking about a 50% increase in the number of programmers. Okay. So not only who's writing these programs, but who's actually not just learning to write programs, because everybody can go to a coding academy for half an hour, can get an $80,000 a year job. But who's learning to secure those programs? Because these programs are doing things, think back a couple of slides, that are critical to our lives. So, yeah, okay, there's the dot-com bubble bursting. Yay. So, but this is the world we live in, and it's not slowing down. So the good news is all of you are going to graduate soon. They're going to pay you lots of money. And you're going to be a wizard because you're going to know more than other people do, but you might not know as much as you need to know to keep yourself off the front page of the New York Times. And that's my goal. I tell every one of my students, I want you not to be on the front page of the New York Times unless it involves going public for a lot of money. Okay. So, education. This is our first line of defense. This is being at a place like this is your first line of defense. But we've got to be teaching the software security process. It's not enough just to teach you about OSs and database and machine learning and theory and all sorts of other important things in the computer science world, great algorithms. How do you know that you're writing code that's safe? Okay, there's all these things we know about, like SQL injections and things, buffer overflows and things like that. But if you use integers wrong, you can be hacked. Declare your integers wrong and you can be hacked. Take my software engineering, talk my software security course, teach you all about it, or look at our videos. We need specific software engineering, software security training. And it's something that's missing from most curriculum. We have general software security courses. We have general computer security courses that cover a whole spectrum of topics and spend just a small amount of time on the software issue. But we're putting programmers out there who are programming devices that control our lives, and we're not teaching this. Training. You go get a job, and does the company teach you how to be more secure? And there are companies like Sands Institute that will charge you $5,000 for a part of a week of training, and some companies make use of that. It's very specialized, but it's not by any means ubiquitous. Companies are not good at keeping up and developing skills of their employees. we have, in the general world, outside of, let's say, medical, we have no requirements on software security. And even the medical device requirements are quite silent on what it means for software to be secure. Automobile industry has safety standards, very strict ones, but security they're quite silent on. The shipping industry has passed new security issues, cybersecurity issues. They're silent on what it means for software to be secure. So as a policy level, as a C-suite person, I don't know what I should be telling my people to do. And so that's the problem. Now, dropping down really quickly to the programmer's hands on the keyboard world, there are tools out there that will be your first line of defense to help find common flaws in your code, static analysis tools. And these are the first 10 or 20% of the solution, but we can't leave that 10 or 20% on the table. We've got to use it. But why isn't, and these are easy to use in general, why isn't every programmer in the world using one of these? Why isn't every company that's developing software that has any face to the real world using these? It's a good question. And for things like critical infrastructure, software we really care about, software that's controlling our lives, transportation, water, power, our toaster, whatever, our underwear, I don't know. Why isn't this software undergoing stricter review in some ways to assure that that there's no attacks in here? Okay, so this is kind of the big picture, and it's the depressing picture. By the way, there's people, a bunch of you with experience in these various fields. Feel free to interrupt me, ask questions. If you have a contribution or an objection to something I say, please stop me from blathering on at high speed. It's the only hope. So one of the things that we've been standing on our soapbox about is where is secure coding, secure design, software evaluation in our curriculum. And as I said, well, we have some of that, a little bit of a taste of it in courses. It's not enough for programmers who are going out to the real world to understand. It's a basic skill. We're not seeing it. And we need to have it, there needs to be, in the OS class, when you're playing around with perhaps C, you need to learn about buffer overruns at that point. When you're in your database class, you need to be looking at SQL injections at that time. We need to be distributing this material. So security is not a separate topic, but security is an integrated part of our thinking. And the hard part is getting the people who teach all those courses to have the materials and the awareness to be able to know to do that. Okay, so our solution, so we're actually trying to help with this. This is a website that's online and free with video lectures and textbook chapters on a bunch of software security chapters. It's about 2/3 populated. It's on its way, hopefully by the end of the summer, to be fully populated. 10 to 20, 8 to 20 minute podcast and a textbook chapter go along with each one of those. Taken all together, there'll soon be downloadable exercises. We've been working on exercises this past semester. And so there'll be online resources. And we just taught this as an end-to-end course this last semester, first time at Wisconsin, first time anywhere. And so we're hoping to get other people to jump on this so more programmers have the opportunity to leave school knowing this stuff. Okay? And for those who are students, you can access the website. For those who are instructors, the resources are there if you want to jump on top of it. Okay. Once you get out of school and you're working in the real world, you need to keep your skills up to date. And there's lots of companies that do this. It's very expensive to get training in this stuff. It's a very high. I'd like, not because I don't like the companies, but because I think we should have this as a part of our education. You're already paying enough tuition. There's no sense paying more when you get out. I'd like to see this industry become less of a need, having more resources, more courses on that. Okay, so much of your code touches the internet, touches the real world, touches people. The notion of an air gap of a network isolated from the rest of the world is no longer considered secure. Stuxnet was a beautiful public example of how security is. So almost nobody's insulated from it. I'll give you a funny example. One of my colleagues says, I'm a mechanical engineer. I'm writing simulations on heat transfer systems. And why do I need to worry about secure programming? Why should my grad students waste time on that? I said, well, do you ever get a data file from a colleague via email? He goes, yeah. Well, there's your attack surface. So even somebody developing on their laptop, disconnected from the world, writing a simple simulation program, they're still, maybe not the most likely one, but even them have to worry about this. So, okay. So let me talk a little bit about something we've been doing under some funding from Homeland Security to try to work to help people with this. And what I'm going to talk about are software tools and trying to give every programmer easy access to a baseline set of resources. But I'll give you, as my linguistic friends say, language shapes thought. So let's use a few terms just so when I talk about tools, we know what we're doing. If you make a mistake in your code and allows the user of your program, by what data they give, to cause the program to do something you don't expect it to do, that's a weakness in your code. We all know that by bugs or flaws in our code. If that all serious security problems start with a weakness in the code, and so we have a taxonomy, a numbering system called the CWE to label it. So if we're talking about different programs, we can compare what kind of weaknesses we have in the code. If we report them, we can actually say precisely, semi-precisely what they are. Now, if that weakness can be exploited to do something interesting against the intent of the designer of the program that has a security benefit, and there's some value judgment there, then we call that weakness a vulnerability. So when you get a tool that scans your program for problems, it's scanning for weaknesses, not for vulnerabilities, though the salespeople love to use the terminology wrong quite intentionally, I assure you. The people who work for companies that sell this scanning software. And the act of taking advantage of a vulnerability to your end, we call that an exploit. So you find if there's a weakness in the code, we try to turn it into a vulnerability, and that act is called exploiting the system. Okay. Just some terminology. So there are all these software assurance tools out there, and they come in a lot of different varieties. I'm going to talk mostly about static analysis tools that scan your code or your binary or your source code or binary or bytecode. And there's commercial tools out there. There's a big market. Tools like Coverity, Fortify, Code Sonar. There's JTest, C-Test. There's a bunch of different commercial tools out there. Companies that spend a lot of time trying to make a tool that's effective. In the C and C++ world, these commercial tools tend to be better than the open source tools. Then there's a ton of open source tools, and basically tools for every possible language. And these can often be very good. Tools like Find Bugs, which is now replaced with Spot Bugs. So you don't have to buy expensive tools necessarily to get this done, but there's tools out there. And it's a huge business space with every assistant professor comes up with a scanning idea, wants to come up with a tool doing that. So there's constantly new ideas popping up. Most tools run locally on your computer, though there are some vendors out there that will sell you the tools as a service, though those are amazingly cumbersome to use and don't seem to be having a lot of traction. Okay, so there's tools for like every language and framework. There are tools out there for COBOL. Some of the old-timers are smiling. Some of the younger folks are going, what's COBOL? Look it up. It's old. Tools run on source or binary or bytecode, and there's a special bytecode for Android apps where you go from Java to bytecode to Android bytecode called DEX, so the tools that scan those things. We're going to talk mostly about static analysis tools because they're the simplest to use. But these tools are awfully very challenging to install. So one of the barriers is they can be complex to install. They can be complex to run. You have to figure out all these options to get right. And if you don't set the options right, you either get nothing interesting or deluge of reports that are so much noise that you don't want to use the tool anymore. Every tool out there reports its results in a totally different format. There's no standardized reporting until a recent standard we developed. A few of the tools label their output with these standardized numbering systems like CWEs, but most don't. And then there's some sad facts. Some of the tools are really fast. Some do very deep semantic analysis, and some are sound. You're not going to have a tool that's both fast and deep. So the tool, and there's no tool out there of practical use that's sound, which means every tool. So you ask a question to some formal system, and it may answer, yes, this property holds, no, this property doesn't hold, or I can't tell. Okay, and what all of these tools do, and especially the commercial ones, is they will tell you, yes, I found something here, or they'll be silent. They really won't tell you how confident they are. They won't tell you when they're not sure. And the marketing people won't let them say when they're not sure, because their competitors will jump on top and go, aha, you have a stupid tool that says it's not sure. Our tool never says that. So, and tools that do sound analysis are just too expensive and very limited. And so there's a problem in this world, and we'll actually see where there's a legal issue that compounds this problem. But this doesn't mean you shouldn't use the tools. You still got to use them. They're the best we got, and they help. Okay. Now, one of the things that you hear in the software students community is no single tool is good at everything. Different tools are good at finding different things. Some will find overlapping results, but they tend to have different strengths, so you need to run more than one tool. And you'll never get a salesperson from a commercial tool vendor to tell you that. They want you in their stovepipe and lock you into their environment and claim that they're, and yes, we have solutions for all the different languages, even though some of those are pretty spotty. So, but in the real world, you really want to run multiple tools and get multiple results to try to get better coverage here and try to get a little corroboration on what the tools are telling you. Okay, so we're not going to talk about dynamic tools. So these tools really do help you, and while they have some difficulties, they are super useful. They're easy to, once you've got them installed and running, which maybe is a challenge, they really do give you a head start on what's going on. So why don't people use? This is not tools, in case you don't see the little not sign there. So why do people not use tools? Well, the commercial tools are expensive. I mean, darn expensive. So they're really hard to install, and they're hard to keep up to date. You have to know new tools comes out, and you have to install it, and the installation processes are not always very smooth. The reports are not always easy to understand by a novice. So if you're not an experienced programmer and the tool tells you something about some dependence in the code that looks sketchy or some kind of security problem that you don't know the name of, you don't always know what it is, and even if you do know what it is, you're not quite sure the best way to fix it. So it doesn't mean it's not important to hear about, it just means it turns off people. If you don't like what the tool is telling you, you just turn it off. There's an old pilot joke. You're flying over the mountains at night in a single-engine airplane, and your engine quits. What do? Well, you turn on your landing light, and if you like what you see, you leave it on. Okay. Doesn't mean the end of your days can be any better, but okay. As I mentioned, getting the options set is tricky. One of the things, if you have a legacy code base, if you have 1 million lines of code and you've never run one of these tools, and finally decide it's time to run it, you run it the first time, and what do you see? On the order of 1 million messages. So, anybody here ever taken a legacy code, especially like a C or C++ code, and turned on a ton of warnings when they've never had them on before? Anybody ever done that? Yeah, and what'd you get? Lots of warnings. And so you turn on your landing light, and if you like what you see, you leave it on. And so there is a solution to this. For those of you who are in the real world or entering the real world or are going to tell people in the real world what they should do, here's a solution we used in one of our research projects where we distribute software that's used commercially all over the world, because we did exactly this. What you do is you make one simple rule, that every time you commit a file, it has to have at least one less warning. Just one. Okay, and that has two really interesting properties. One, obvious, is monotonically decreasing. Okay, two, programmers are incapable of fixing just one warning. It's like potato chips. When's the last time you ate one potato chip? Or corn chips. I like those better. I'm raised in Southern California. I like tortilla chips. Okay, so programmers will fix between 10 and 15 just by observation. Empirically, I've noticed that, so science to it. And given about 3 months later, you'll probably have wiped out 70 to 80% of your warnings. And you start reducing the noise. I have another flying story. I have a colleague who's an architecture professor at MIT. He's also a pilot, flies a Cessna 210, nice single-engine, beefy airplane. Used to fly from the Boston area up to Chippewa Falls to consult for Cray, and fly back and forth. And the Cessna has an low pressure gauge that has a red warning light when you get low oil pressure. And his oil pressure light was wonky. It just would go on randomly. And he got in the habit of ignoring the oil pressure light, because it would just always go on, and they couldn't figure out what's wrong. One of those electrical gremlins they couldn't get fixed. So one day he was landing at Islip Airport on Long Island, and Long Island approach, New York approach likes to vector you way offshore, low over the water, back in. Bad thing when you're a single-engine airplane. And his oil light went on, and he said, oh, okay, tap, 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 fine, I'll land. 7 minutes later, he was standing on the wing of his airplane in the water, waiting for the helicopter to arrive. So, okay. Okay. Now, so we can fix security, we can fix legacy code bases, and it's not that painful. It's scary at first, but it's not. Security flaws slow down software delivery. The Cray 2, when it was being delivered, this testing group, not looking for security, but looking for correctness problem, found a ton of correctness problems in the code of the operating system, utilities, whatever. Forced Cray to delay delivery of the Cray 2 by a quarter. That caused their profits to decline, and the company saved money by laying off the testing group. Okay. But we need these tools, and we need to make them easier to run, and so that's what the Software Assurance Marketplace, the SWAMP, such a lovely acronym, is about. We were funded about 7 years ago by the Department of Homeland Security to S&T is Science and Technology, their research arm, to try to stand up an open facility where you could upload your program, push a few buttons, run against whatever collection of 3, 4, 5, 6 tools you wanted, and get your results back in a unified view, such you only had to understand one mechanism to upload, and the view was the same for every tool for the results. And this was a consortium, a bunch of crazy academic groups that DHS decided it could stand up an operational facility, which is interest for those of you who are faculty investigators. This is a very different kind of activity, and DHS is actually less fun to work with than you can imagine.
It's being recorded.
One of our two senators sit on the Senate Homeland Security Committee. One's chairman, so I don't know. Maybe that's cover. Otherwise, I've got tenure. I can go do something else. Okay. So our goal is to build a software assurance community. So for software developers, it's a place to run your stuff against tools, not worry about installing them, keeping them up to date, configuring whatever. Just upload your code and get them to run with a great deal of automation. And there's some very interesting things to do to try to make these things more automated. And that's a whole offline discussion, but it's something that the commercial developers do very well. It's something we do and provide for open source for all the people who are trying to do this in their garage shop. For tool developers, it's a place to go to deploy your tools, run against standard packages that we have, and get exposure to new customers. And we support tool developers with a lot of infrastructure software. For researchers, there's a lot of data here about all the assessments we run, all the results we get, and as long as we anonymize the data, we can provide data to people who want to study the software engineering process with respect to security. And for instructors, it's a platform to introduce software assurance. We've had high school AP classes use it. Every assignment has to be run against the tool. We had data structures class uses it. My operating system class had to run all their C code against it. We've had graduate security classes who want to understand the limits of tools and do comparisons. We've had undergraduate security classes use it. So it's just there for instructors to use and has some facilities to identify classes and give instructors the right permissions and things like that. So we're trying to do a bunch of different things. So we want to make it easy for you to upload a software package. That's an application. We call it a package. We want to make it easy for new tools to be put into the Swamp so you can try out your tool. And we're good at working with tool developers to know how to show them how to make a tool that can be used. It's all open source. So it's if you want to play around with the platform, you can download and run your own local Swamp. And use that. In fact, if you're a company and you can't upload your software to the Swamp because of confidentiality or perhaps security reasons, you can run your own local copy of the Swamp, which has the lovely name Swamp in a Box. So you can download your version. So if you're a newbie, never done this kind of stuff, it's a great way to get started without having to know anything. And if you're an expert, you can access a ton of tools without the pain of being the one to maintain them or argue with your IT group of why they should maintain them. And it's an easy way to bring multiple tools into the same place. So now, we coined this term called continuous assurance. Continuous assurance is the natural follow-on to continuous integration. As you get into this design code, test integrate cycle, where you're continually making commits, doing small running against your test suite, part of that commit discipline should be running against these tools. So every time you do a commit, every time you do an update, you should be looking at these tools and fixing those problems early, because we know that the cost of fixing something early is enormously cheaper than doing it later in a project, and God forbid doing it post-deployment, which is very expensive. And there's all sorts of software engineering data about that. So what we're trying to do is make a cultural change where every programmer expects, just as part of what they do, every time they make a commit, they make a quick look at the tool output to see what changed. It shouldn't be a very big deal, and addressing it then. Once you get past that initial curve of the early warnings, or if you start applying the tools from day one, then it's just a quick check, and this just runs in the background. And we've tried to make this much easier to run, where if you're using something like Eclipse, there's a Swamp button on Eclipse. You push the Swamp button, and the software gets packaged, uploaded to the Swamp, assessed, and back on a new canvas with a code view of the roles. If you're in Jenkins and you're doing a CI cycle, a commit cycle under a continuous integration tool, every time you do one of these cycles, it uploaded, assessed, and comes back, and you look at it in the tool. If you're using SVN or Git, or maybe using GitHub, there are plugins there such that every time you do a commit, it gets uploaded and assessed. Well, there's no GUI there, so you have to go to the Swamp and use the web viewer and look at the results. But every time you do a step in development, you can just put it in there so it becomes a natural thing. And that's crucial to create this cultural change there. Okay, so Swamp has lots of tools there for lots of different languages, and there's lots of new stuff coming. We're going to start supporting containers, software that comes in containers. We're going to start. Windows is on the way. We actually have .NET not running under Windows, but running under the portable Linux environment. Windows is coming up. The Windows is a god-awful pain in various places in your body. It's just unpleasant, but it's all there, and we just keep, and we're adding new tools and environments as we go. So now, if you're in an organization and you say, let's use tools, you end up getting answers. So we're playing Jeopardy now. These are the answers, and we got to figure out what the questions are. So answers like, what? No thanks, we really don't need it. Oh, right, but we really can't afford it. Didn't we already take care of that already? We'll get to the questions in a second. So just remember those. Just remember the answers. So the problem is tools have their limitations. They're slow or limited or hard to understand. Hard to understand we can figure with education. Limitations we have to address with something else, and I'll talk about why the law is working against us there. We don't really know how good these tools are. There are legal constraints that prevent that. That's what I'm telling you about. And so we'll get to that in a second. Okay. So if your company does not have a software assurance process, it usually ends up in the lap of the testing group, and they go, I don't know nothing about security. So they go, what? And then after you explain to what it is, they say, oh, we can't afford it. Okay, and then you have to explain to them all this open source or the swamp. They go, well, it's too hard to install, whatever, so we really can't do that. And when you get all done explaining to them, don't we already handle this already? Aren't we already, so, and then they say, didn't we just do a risk assessment of our product? And a risk assessment says, yes, there's a 30% chance you're going to be totally screwed. Pardon me, this is recorded. That doesn't tell you where or how to prevent it. It just tells you what kind of insurance to buy and when to start interviewing. So, so confusing people with doing vulnerability finding with risk assessment is often very difficult. And the tools are far from perfect. But so how do we know how good they are? Because no one publishes comparison studies anymore. No one. And we'll talk about that. But there are these calibration test suites. NSA and NIST came out with the Juliet test suite. IARPA came out with Stone Soup. And there's more recent work from DHS that's being funded right now. Juliet's got tons of little micro tests with false and true positives in there that you can calibrate against. Stone Soup has large programs that have been permuted to have vulnerabilities in it. Bug Injector is a recent tool that will take your code and permute it to put vulnerabilities in, not for product release, of course, but to help validate tools so you can test it in lots of different circumstances. So there are these great calibration suites out there, and they're all in the swamp. They're all available. Now, I'd like to write a paper and publish it. Turns out in 2009, we did exactly that. After doing a lot of in-depth manual assessment, which I'll talk about in a few minutes if I don't run over too much, we actually did a study. We did a study of the Condor system many years ago. Those of you know it's a major scheduling system that's used worldwide for everything. The Higgs boson was found with the data analysis, so they have a Nobel Prize to their credit. All your favorite Pixar and ILM movies are rendered using it. Embraer simulates their aircraft with it. So it's a moderately important system. We did a study of it to see if it was secure. We did a net vulnerability manual-driven one, which I'll tell you about in a second. Found 15 serious vulnerabilities. We said, well, I wonder if the tools, at that time, Fortify and Coverity, were the best out there. And these particular versions, I had to put the versions down to be careful to keep from being sued again, because we've been sued once. And we found out that Coverity found 6, Fortify found 6, Coverity found 1, and gave tens of thousands of false alarms in the process. So, so these tools, and this was really useful, valuable stuff. We had the right license to publish the stuff, but Coverity decided we didn't. They went legal on us, which got our campus legal team loves academic freedom fights. They just live for academic freedom fights. They just love when we get sued, and they went junkyard dog all over Coverity. And it was the most fun exchange. It was like British rudeness, politeness covering knives and sharp swords and things like that. It was really fun to watch. Coverity shut up. And we wrote a paper Manual versus automated assessment. That was cool. You can't do this anymore. We were lucky to do this, and it's actually all Wisconsin's fault. Any database researchers in here? David DeWitt, one of our retired emeritus professors, very famous senior database guy, he was famous for doing benchmarking and parallel performance database systems. And way back when he was a kid, assistant professor, he published a study comparing a whole bunch of object-oriented database systems and included Oracle. And Oracle came out looking rather bad. Larry Ellison called up a department chair and said, turn off the recording, fire the bastard, turn on the recording. And our chair says, we don't do that. Well, we do that, but not because you don't like its results. And so he called up, so Larry Ellison, who's not a very nice man, put that on tape, and he called up our campus administration, fired the gentleman, and they didn't choose to do that either. And as a result, they put a clause in called the DeWitt clause, which says you can't publish any results of correctness or performance of our software. Shrink wrap license, you install it, you can't say anything. You're driving down the highway, the front wheel falls off your car, you can't tweet it. The automobile industry had the same thing. You cannot publish anything about the internals of our ignition software. People might see the software and dork with it in such a way that would distort its proper purpose, and we don't want you doing that. That's because we're doing it ourselves. We're Volkswagen. These are clauses from real tools, real commercial tools. You shall not perform, publish, or release any third-party benchmarks, blah, blah, blah. You may not disclose software output, including not limited to the results of blah, blah, blah. Customer will not disclose to any third party any comparison of the results with blah, blah, blah. These are all real licenses. Okay, these are all DeWitt clauses. So you cannot do a Consumer Reports article on which tools to use. You as a manager cannot say what's the most effective tool I should be buying. You as a government policy person can't say, I wonder how good the tools are, what should we require? And this needs legislative release. Okay. We met with the Senate Homeland Security Committee, and they were busy with walls or something. So we hope they'll get back to this when they finally get the wall built or whatever they do. Okay, so the lack of transparency here, I believe, is not just a national but an international security issue. So last thing I want to talk about is the kind of fun and trouble we get into. So for critical infrastructure, we got to run those tools. And I told you all the reasons why they're terrible, but you got to run them anyways because they're the best we have. It's Churchill's democracy. It's the worst of all possible forms of government, except for all the others. You got to do it. But that's not enough for critical infrastructure. If you're getting 20%, you're leaving 80% on the table. And if you're running a power plant or a ship or a boat or a self-driving car or a water system or whatever, or your underwear, you got to get that right. Okay. And so we developed a methodology. We were told you a long time ago to look at Condor, and there were no methodologies out there. So we kind of developed one on the way. It's very analyst-driven. We're developing some tools to make it go faster, but it's still time-critical, time-intensive. We call it FPVA, First Principles Vulnerability Assessment. And so we've done this a long time ago, and we've applied this to lots of infrastructure. More recently, to shipping. So first, the whole idea of FPVA is focus on the critical assets. What are the high-value assets? Exploiting every feature of a system may not be of equal value, and if it's a million lines of code, you can't look through a million lines of code. So you got to figure out where they are. You want to look for known vulnerabilities, but if that's the end of your day, you're not going to stay ahead of the bad guys. So we got to have something that's not dependent upon known vulnerabilities. This is a whole long discussion. We have some papers on it, and there's a video on it, so you can learn about it. But basically, the idea is identify the architectural components in your system, processes, threads, main components, identify the main resources, things like files and databases and external services, try to figure out the value of those, add user IDs, trust and privilege, figure out how they communicate, how they delegate privilege, and you get this flow diagram. Show this flow diagram, which usually fits on a page or two, to the development team, and they'll go, oh, I didn't know that ran its route. Oh, I didn't know that module was talking over there. All by itself, if you spend the time just doing this, the developers will love you. The very first time we did this with the Condor group, we didn't know what we were doing. We had this diagram. We thought it was pretty good. And we showed it to the 20 developers. And we spent there an hour and a half as they said, oh, my God, we did this? Because even if they had documentation at the beginning, it's not up to date anymore. And most of the time, they don't have the documentation. Then you start digging into the components that you say, oh, these are high value. This runs as root. This is a critical database. It has names of programs other people are going to run. So if you work with that, you can run anything. And then you use that to direct where to look in the code. Okay, so this is the process told too fast. That's a lot, and I can learn more about that. We've got good papers on that. So we started looking at shipping and said, there's a lot of money. 90% of the world's commerce goes through container shipping. People like to send drugs through container shipping, and not the good kind of aspirin and antibiotics kinds, the kind that's but. And these shipping lines are carrying really heavy boxes high up over our heads and moving them very fast. And if I dork with the ship database, and I tell the ship that all the light ones are over here and all the head ones are over there, and you load the ship that way, and I lied, as soon as you go out to sea, the ship rolls over. There's a lot of really interesting bad things you can do, and these bad things, if you shut down a container port, cost $1 billion a day. How do we have good numbers on that? Well, longshoremen have been striking for, we have, the oldest document I can find is 2,500 years ago, a Greek document about a longshoreman strike. And so they've been writing, people have been complaining about longshoreman strikes. We have good economic data on this. This is a diagram that didn't exist before we started. This is half the diagram from the point when something is on the ship to the point it arrives at its destination. And these are all the entities. You don't have to read this carefully. I've got this in the doc. I've got this in some papers. You can look at it carefully. But these are all the entities that are going to get electronic transfers of data to make that container get where it's going to go. Manifests and legal stuff and custom stuff and weight stuff and permission stuff. And everything in red, which is like, it's hard to find a green line. Maybe there's a green line here, and there's a couple of green lines here. Everything in red is electronic transfer that's not standardized or encrypted or authenticated. Memory sticks handed around. The ship's master hands the port master a memory stick. Or you get an email. Dear port master, here are some boxes. Okay. So these things, ICT, that's it's just the name they use for information and computer technology. So they're at risk because they use software. We talked about vulnerabilities. The systems that run the container terminal ports are called terminal operating systems. Nothing to do with a real OS. It's what they call the thing that control the boxes and the cranes and the robots and the scanners and things like that. Those boxes are just metal boxes with serial numbers. No labels or paperwork. Scramble the database. You don't know anything. Okay. So again, a lot of work in risk assessments for a port. You read all these papers, and each one gives you more and more refined knowledge that there is a 40% chance that cyber will really screw up your day in this port. But how do you fix that? So that's what we decided to do. We did one of these FPVA assessments on TOS PCS. Now we're a bunch of academics. We needed the source code. Okay, so let's tell a little bit of story. I've asked, anybody been to Barcelona? Anybody been to Barcelona? Anybody been up on Montjuic where the Olympic Stadium is? And if you look go all the way up to the fortress and look back down on the backside, this is the view. Okay, I spent part of my year in Barcelona. That's what happens when you pick the right spouse. And you see the container report in the airport. And we were up there one day, 6 years ago, going, that's a lot of boxes. It's not a very big port. It's not as big as one of the big Asian ports, or maybe as big as LA, Long Beach. What happens if I scramble the database? And so we started thinking about this problem. Because, like I said, these boxes are just big metal boxes with serial numbers on them. There's nothing that tells you what's in them. There's no paperwork. There is no paperwork. Okay? It's that serial number that tells you the whole story. So we tried making some phone calls. We had the people threaten to call the FBI on us because we were dangerous. We got in touch with a research institute in Valencia, Spain, that was associated with the Port of Valencia. A long story there, but we got there. They connected us with a terminal operator, people who owned one of the terminal yards in the Port of Valencia. In autumn, we started telling them about threat models. They freaked out. That's us standing there. Because they showed us all this. We freaked them out. They showed us everything about their environment. So the idea is, tell somebody something scary and they'll give you all their secrets. Okay. Well, we had a letter from NATO and a letter from the Defense Department, so that helped. We didn't threaten to hurt anybody or anything. So they put us in contact with one of the two world providers of the software that runs at ports, a company called Total SoftBank. I now have permission to use their name. We've co-authored papers together. We went into their system. They sent us, after talking with them, 6 years after standing up there a bunch a week, I had a virtual machine with all of Total SoftBank software in it, source code, ready to build. If you wait for you can't do this as assistant professor, you'll die. You'll end up in industry. So we couldn't believe it, and so then we immediately trained up a new undergraduate and started looking for vulnerabilities, ones we could exploit. Okay. So basically, I'll tell you real quick, some really Bush League stuff like all their protocols were HTTPS, but if your browser told the server you didn't have HTTPS, it would default down to unencrypted. You got to turn that off. That's Bush League. Could have found that easily. The fact that passwords were encrypted, not hashed, meant you could reverse them. And they go, you're right, but nobody can get our password database out. 3 days later, the student says, I've got an arbitrary file exfiltration vulnerability. And we handed them their password file. It was good. It was like, can't plan those things. A lot of the validations of operations were done in the client code, the JavaScript running in the client. You can't trust the clients. Clients don't, clients you can dork with anything in your laptop. You got to revalidate stuff on the server side. Don't laugh, this could be your software. I'm going to do your software next. Okay? This allowed people to do all kinds of arbitrary things and allowed to get administrative privilege. They were using old versions of software. Software supply chain resource management is crucial. No matter how good you are, if you're trusting somebody that's weak, it doesn't happen very often. And when it happens, it's limited. There's this obscure case of OpenSSL and Heartbleed. So not only do you so there are tools out there for checking your supply chain, like OWASP dependency check for the Java world. Very important to use tools like that. Because no matter how good you are, if you're using somebody else's stuff, and we're all building some frameworks, if you're using WordPress and you're using a non-WordPress plugin, you're just screwed. Just get rid of all your passwords and let the bad guys have 5 minutes of easier access, because that's the only difference. Okay, so the wrong dependence will kill you. And we had a vulnerability where they were having an operation request and a function they wanted to execute, and the operation request was checked to see if it was a legal one. And if they did, they'd execute the function you had. And this was really weird, because you can say, the operation I want to do is nothing. And they say, okay, you can do that. And the function I want to call is delete the database. And they go, okay. It was just a weird piece of engineering that two different groups didn't talk to each other, and I thought you were doing it. Okay, so we found some more. After about 6, we got up to 7. They were pretty traumatized. But they asked us to do it. It's like, hit me again, please. So we work with them to make fixes, because people have this panic reaction when they get vulnerabilities and want to fix it in the most, I have something called the concept of minimal fix. It's what's the minimum number of keystrokes in Vim that will change your code to get rid of the behavior. And that's not always the best measure of how to fix something. That's what programmers want to do. So we worked with them through several rounds. They freaked out. We went out there in Busan, Korea. So we went out to Busan. Love lovely city, great food. Went out there, ran a 3-day training course. Took all the developers offline for 3 days. Ran them through a whole kind of the subset of what we teach in our semester course. And they subsequently were asked to compete on contract for Maersk Shipping. Maersk, who got hit a couple of years ago. That's a whole other interesting story. Maersk was very security sensitive, said, we want you to bid on this, we like your stuff, but beware, you're probably going to take you 3 tries to get through our security screening. Total SoftBank, after this, got through in the first try. And we were very excited about that. We got this long flowing email about just we got reservations next trip for the really good Korean steakhouse. We published. So, Arnold here is CTO of Total SoftBank, and we published and told people this whole story. I'm allowed to say their name. We jointly published. We've got a journal article in the transportation sector out there. This is a popular trade magazine, so all their customers and competitors could see this. We try to tell companies that you've got to make your security process visible. You've got to tell them the bad news. You've got to tell them what you're doing about it. Because if people don't see a security process visible, they think either you're not doing it or you're not telling. Both are bad. And if you tell them, you will get a lot of credit. Ron Livney, who runs the Condor project, many years ago did this with us, and we said, we want to publish this. And he goes, oh, I'm nervous, but go ahead. He's got an enormous, he is the poster child at NSF for how to deploy reliable cyber infrastructure. And these guys have gotten a huge contract with Maersk, and they're getting a lot of customers jumping on them. So we think this is a great object lesson. So you can read the article. They're out there to read, and I'll make these slides available through George. Okay. So I said we went there. We taught class. That's us teaching their group in Busan. And that was a great time. Okay. I'm going to say one more quick thing. I know I'm running long. If you need to go, you're not going to offend me. My students walk out all the time. Maersk Shipping who has 17% of the world's shipping, got zeroed by the Russians. Their computers were turned to useless machines that didn't even have a valid BIOS on it. It took 2 minutes. 10,000 computers worldwide were reduced to nothing. And they spent, even though they said, oh, we lost $200 or $300 million, they lost billions. And delayed shipping. And they had no plan. They had lots of plans for keeping the bad guys out. They had no plans for what to do when the bad guys got them. How do you recover? The Navy calls this fighting forward. How do we have a continuity of operations plan? Do you have a copy do you know what's on every computer you're running? Do you have a manifest inventory in a non-writable location? Write once, read-only site. Do you have copies? Do you have VM or VM images or containers for everything that runs on every host in your environment? And can you pull it off the shelf right now? And have you validated that it's usable and not already encrypted or dorked? If not, your confidentiality, integrity, availability, all those efforts are for naught because the bad guys will get through. And the amount of time it took to get Maersk back on their feet was enormous, and it cost them billions. So we need some continuity of operations. And like I said, cloud, virtual machine model. Okay. I rambled. I want to give people a chance to leave if they need to go somewhere else, and a chance to ask questions for anybody who's got the time to stay around. Thank you.